Hi there and welcome back. You're watching the lesson on decimal numbers. In this lesson we're going to explore the relationship between decimals and fractions, and by the time we're all done you'll be able to add, subtract, multiply, and divide decimal numbers without a calculator. So let's get going. So you might be surprised to know that when we look at either fractions or decimals and think about which system was used first, a lot of people assume that decimals were around first and that fractions came by later because people perceive fractions to be more complicated. But in fact, fractions were used by civilizations for hundreds of years before the decimal system was developed. Decimal numbers are just fractions, actually. It's just a shorter way of writing fractions which have something in the denominator. And if you think about it, when we think about decimal numbers like 0.3, 0.981, and 6.36, we can write all those as fractions. What would they all have in the denominator that makes them sort of special? Well, it's the fact that they have some power of 10 in their denominator. That is to say, decimals are always fractions that can be expressed over 10 or 100 or 1,000 or so on. So let's see what that looks like. Our first example here is 0.3. Notice that there's only one decimal value there, and that tells you that we're in the tenths place, and so this fraction is going to be 3/10. Notice that there's one decimal place, and therefore there's 1 0 after the 1 in the denominator. Following that idea, 0.981, we'd say that's 981. Since those are three decimals, we'd say it's 981 thousandths. Three decimal places there, 3 zeros in the denominator. What about 6.36? That 6 is just going to stay out in front, and we have two decimals, therefore we should have 2 zeros after the 1 in the denominator. That's 6 and 36/100ths. Now that fraction could be reduced down, but for our purposes we're going to leave it just the way it is. What about going backwards? We can take fractions that have some power of 10 in the denominator, and we can turn them back into decimals. So here again, the number of zeros in the denominator has to correspond with the number of decimal places. So 23/100ths, that has to be 0.23. 2 zeros, 2 decimals. 7/1000ths. Now, we know we're going to have 3 decimal places to push out to the thousandth place, and the only number that can be there is a 7, so that's going to be preceded by 2 zeros, 0.007. And our last one, 9 and 120 10,000ths. We need to have 4 decimal places to get out to the 10,000ths place. But our number, our numerator, is only 120. We're going to have to put a 0 in front of that, and this becomes 9.0120. Now you may have noted that we don't really need that last 0, and in fact the zeros could have canceled in this fraction. But oftentimes when we take measurements, those zeros are significant because they show a level of precision in the way that that number was measured. So in general, we'll keep those zeros on there. We'll talk more about that in just a little bit. Okay, the other thing that we need to recognize is that we often round numbers because there's a certain point at which we just don't care about the small place value. So a little refresher, starting at the decimal point, counting whole numbers, we have the ones place, the tens place, the hundreds place, thousands, 10,000s, 100,000s, all the way out to the millions. But for our purposes and most of the work we're going to do, we're going to be rounding to part of a whole. That is to say the 10th, the 100th, the 1,000th, and maybe the 10,000th. We don't have anything that will be rounding any smaller than that. So do you remember what the rounding rule is? After we decide where we want to cut our number off or truncate it, we have to decide whether that last digit should stay or go up. Your last digit doesn't change if the number to its right is, do you remember what that is? Well, it's 0 through 4. When we decide to cut off a number, if the next digit to the right is 0 through 4, then we leave the last digit we kept. If the digit to the right is 5 through 9, then we round up. So let's take a look at a couple of examples of this. Okay, let's round 23.6387 to the nearest hundredth. The first question we have to ask is, okay, hundredth, how many decimal places is that? Hundredth is 2 decimal places, which means we're going to truncate the number after 2 places, but when we round, we have to look 1 place to the right. So since that place to the right is an 8, that's enough to make our last digit round up, and we would call this 23.64. Our next one, 6.84837 to the nearest thousandth. Well, thousandth means we're going to keep 3 decimal places. We're going to cut it off after the second 8. And this time the 3 is not big enough to send our last digit up, and so we're going to call that 6.848. It's going to stay right where it is. All right, what about 84.449? This is an easy one to misinterpret. Where would we round that off? Well, if we're rounding it to the nearest tenth, that means we're going to keep only 1 decimal place. And so this is going to be 84 point something. Now if we look 1 place to the right, that's a 4. If the place to the right is 0 through 4, we leave our last digit the way it was, so we're going to leave that at 84.4. There's some temptation to round that up to a 5 because there's a 9, but that 9 doesn't matter. We're not looking 2 places to the right. We only care about the first place to the right. Nothing beyond that matters, no matter how many 9s there are. Be careful of that. That's an easy mistake to make. Okay, adding decimals. We're getting to the point where we're going to be using a calculator pretty soon, but these fundamental arithmetic skills are important to refresh. So if you rebuild the carrier in a rear axle in a rear-wheel drive vehicle or a front-wheel drive vehicle, you will oftentimes be dealing with shims, and you'll have to add up the thicknesses of those shims to get the components of your differential and all the gears meshing in just the way that they should. So suppose we have a carrier with shims of 265 thousandths, 16 thousandths, and a couple 4 thousandths shims. What's the total shim thickness? Well, we're going to add those up. The only thing we need to keep in mind is when we add up decimal values, the decimals have to align. So we're going to add up 0.265, 0.016, and 2 of those 0.004. Okay, our decimals all align, and we can add 5 plus 6 is 11, 15, 19, and we'll carry our 1. 1 and 6 is 7, 8. Our decimal follows straight down. The total thickness there is 0.289, or 289 thousandths. Well, subtracting is very similar. You do this when you check tolerances. Oftentimes you find out how far away from a nominal value you are. So the maximum allowable diameter of this brake drum, that is to say the biggest we can machine it, is 9.200 inches. We measured the drum to be 8.967, so the question is how far below the maximum are we? We're clearly less than the maximum diameter, so the drum is good, but let's find out how far below that we are. We need to subtract 9.200 minus our measurement of 8.967. Now be a little bit careful here. We're going to have to take 0 minus 7. This is similar to the work we did in fractions. We can't take 7 away from 0. We need to borrow. But there's nobody to borrow from next door. So we have to go 2 spots down. That 2 is going to become a 1. What does that make this 0? Makes it a 10. But immediately that 10 is going to become a 9 because we're going to borrow one of those and make our next digit a 10. So 2 became a 1 so that the digit to the right could become a 10. And then we borrowed one of those, it became a 9 so that the digit to the right of that could become a 10. Now we can do our subtraction. Be real careful when you're subtracting from zeros and doing multiple borrowing steps. 10 minus 7 is 3. 9 minus 6 is 3. Now we have 1 minus 9. We can't do that. Let's borrow from that 9, make it an 8, and that becomes an 11. 11 minus 9 is 2. There's our decimal point, and 8 minus 8 is 0. So the difference is 0.233 inches. We're 0.233 below the maximum. Okay, here's a practice problem for you. The turbine shaft for a turbocharger should have a diameter of 0.675 plus or minus 5/10,000ths. We measure it and it's actually 0.6743. So the question is the shaft within tolerance? Let's find out what our measurement is from what it should be and see if we're within those 5/10,000ths. Go ahead and do that and unpause the video when you're ready to see your solution. Okay. The shaft should be 0.675. We're measuring ours to be 0.6743. Ours is a little bit smaller. That's going to mean that we should take 0.675 and we'll subtract 0.6743 since our measured value is smaller. Now notice here that we don't have a 10,000ths place on this number. So we're going to go ahead and insert a 0 there just so that we can perform our subtraction. Okay, 0 minus 3, we can't do that. We're going to have to borrow. That 5 becomes a 4, and this becomes a 10. 10 minus 3 is 7, 4 minus 4, 7 minus 7, 6 minus 6. There's our decimal point. The difference is 7/10,000ths. But the tolerance was only 5/1000ths, and so we're a little bit too far from the nominal value. And so is the shaft within tolerance? No, it's not within tolerance. We're 7/10,000ths off. We're only allowed 5/10,000ths. How far out of tolerance is it? Well, the first 5/10,000ths would have been okay. But it's pretty clear that we are 2/10,000ths out of spec. Okay, multiplying decimal numbers. Suppose at work you work 38.5 hours one week and you get paid $16.75 per hour. What's your gross pay? There's 3 ways we can set this up. I'm going to write this problem 3 ways. I want you to tell me which of these 3 ways is correct. Okay, here's your 3 options. 38.5 times 16.75, 3 digits on the top, 4 on the bottom. Option 2 is 16.75 times 38.5, 4 digits on the top, 3 on the bottom. Or 16.75 times 38.50, and I put a 0 at the end of that 38.5 so that the decimal lines up. Which of these is correct? Well, technically they all are. I mean, this problem can be done, any of these. They're all true. But there's one way here that's best. So we don't need to line up the decimals when multiplying, so that just adds more work. And we also usually try to put the fewer number of digits in the bottom of our multiplication, and that saves the amount of writing we have to do. So we would use the middle option here. So a little refresher, we first take our 5 and multiply it across the top row. 5 times 5 is 25, we'll carry the 2. 5 times 7 is 35, 36, 37, and we'll carry that 3. 5 times 6 is 30, plus those 3 are 33, and we'll carry the 3. 5 times 1 is 5, 6, 7, 8. That takes care of row 1. In row 2, we'll multiply the 8 around everything across the top. But since we're moving in a spot here, we have to move in a spot in row 2. So I'm going to put a little arrow there to indicate that we're moving in a spot. 8 times 5 is 40, and we'll carry up that 4. 8 times 7 is 56, plus that 4 is 60, and we'll carry up a 6. 8 times 6 is 48, plus 6 is 54, and we'll carry up the 5. And 8 times 1 is 8, plus 5 is 13. Okay, now we'll multiply the 3 by everything in the top row, but since we've moved in 2 spots there, we want to move in 2 spots here. And so 3 times 5 is 15. We're going to carry that 1. 3 times 7 is 21, plus that 1 is 22. Carry the 2. 3 times 6 is 18, plus the 2 is 20, and we'll carry that 2. And 3 times 1 is 3, 4, 5. Now that we've done all that multiplication, we're going to add up all these columns. We have 5, 7, 8, 14, and we'll carry that one, 4, and 6. Now, 644,875, that's certainly our result, but we've got a decimal point in there somewhere. Notice the decimal doesn't line up, so that doesn't tell us where the decimal goes here like it does when we're adding or subtracting. Instead, we count total decimal places. 16.75 has 2 decimal places. 38.5 has 1 more for a grand total of 3 decimals. That means our answer also has to have 3 decimals from the right. 1, 2, 3. And our result is 644.875. Since this is money, we could round that off at $644.88. Now again, we're right on the edge of the work we're going to be doing with a calculator, but understanding those principles is always a valuable thing to do. The more you can do this kind of work, the easier math is for you. And in fact, I'd like you to answer this question. Dirty scrap brass is worth about $1.20 per pound right now. If you've got a junky old radiator that weighs 8.5 pounds, what's the value of that scrap radiator? Take a minute and multiply 8.5 pounds times $1.20 per pound and unpause to see if you get the right solution. Okay, well, we're going to take the number with more digits and put it on top. So $1.20. And we're going to multiply that by 8.5 pounds. Our decimals don't need to line up. You certainly could ignore that 0 and write this as $1.2. We're just going to multiply it the way that it is. So let's first of all multiply the 5 by everything in the top row. 5 times 0, 5 times 2 is 10, and carry the 1, 5, 6. Now we're going to multiply the 8 by everything in the top row. We're going to move in one spot since the 8 is in one spot. 8 times 0 is 0. 8 times 2 is 16, and we're going to carry that 1. 8 plus 1 is 9. And when we add these up, we get 0, 0, 12, carry the 1, 10, 10200. How many total decimal places do we have? We have 1, 2, 3 total decimals, so we want to go in 1, 2, 3 total decimals, and our answer is $10.200, or in other words, $10.20. Okay, let's just take a look at a couple of division problems here, and it's certainly probably true from a practical standpoint that if you have to divide two numbers, you're probably going to pull out your cell phone and use your calculator on there. But again, it's really my goal for you to understand the principles that are going on with division, so we're going to do some simple division problems here. If you buy a box of 8 hose clamps for $6.79, how much are you paying for each of those 8 clamps? Well, we're going to take that $6.79 that you paid for the box and find out what the value is of each of those 8 clamps. In other words, we're going to divide that into 8 equal parts to find the value of each clamp. So, our divisor is the number outside. We like it when the divisor doesn't have a decimal in it. That means that the decimal inside, in what's called our dividend, doesn't have to move. We can just bring it straight up above. And here we go. We've done this a little bit when we were working with fractions as well. Does 8 fit into 6? Nope, it doesn't. So we could put a 0 above there. How about 67? Does 8 fit into 67? Yeah, it does, 8 times. 8 times 8 is 64, and we subtract. That leaves us with a 3. Now we can drop our next digit, and we get 39. Now, does 8 fit into 39? Yeah, it does, 4 times. Now we can't quit there. We're talking about 84 cents or so per clamp, but let's get one more digit to see how it rounds. 4 times 8 is 32, and so we subtract and get a 7. We don't like remainders though. To get one more decimal place, we're going to pretend there's a 0 on the end of that and bring it down. 8 goes into 70 8 times, and that's good enough. We can quit because we now know that this 8 is going to be big enough to cause our 84 cents to round up to 85 cents per clamp. Okay, one more just for completeness. When you figure out your gas mileage, we always divide the number of miles driven by the number of gallons used. And when we do that, we get our miles per gallon, or our fuel economy. So let's figure out what we have here. We're going to take 215.7 miles, and we're going to divide it by the number of gallons used. That goes on the outside. That's 8.4. Okay, that number on the outside, remember what that's called? That's your divisor. The number on the inside is our dividend. And our answer, I don't think I mentioned this in the last problem, our answer is called the quotient. So let's figure this out. Now this time our divisor does have a decimal in it. We don't like that. So we chase it off to the right so that it's gone. Instead of 8.4, we make it 84. But if we move that to the right, this one on the inside also has to get moved to the right. And so we could rewrite this problem as 2157 divided by 84. But we can just bring the decimal up one spot from its new location to the right of the 7 and start the problem. Okay, don't pay attention to the decimal anymore. Once we've got it located, it really doesn't affect our work. So, does 84 fit into 2? Nope, not going to put anything above there. Does 84 fit into 21? Nope. Does 84 fit into 215? Yeah, 84 does fit into 215 2 times. 2 times 4 is 8. 2 times 8 is 16. And when we subtract, we get 47. We drop down our next digit. What about 84 into 477? Well, 5 times 80 is 400, so we're in that neighborhood. Let's suppose it's a 5. 5 times 4 is 20. We'll carry that 2. 5 times 8 is 40, plus 2 is 42. It fits in there. We're left with 57. Now let's get one decimal place here. So we'll pretend there's a 0, and we'll drop that down. 84 into 570? Well, it's going to be a little bit more than 5 this time. It's probably about a 0.6. So we're looking at around 25.6, but we could round that up and say that we are getting about 26 miles per gallon. And we can round that up to 26 because we found our first decimal point, and that is enough to send the 5 up to a 6. If we wanted to know more specifically than that, probably, realistically, we'd get a calculator. Okay, I'd like you to do this last problem for practice before we wrap up. A driver travels 126.5 miles and they take 2.5 hours. So my question is, what is the average speed? The idea here is that we're going to take the number of miles, and if we divide it by the number of hours, then that'll give you the number of miles per hour, or in other words, the driver's speed. So go ahead and do that division. You're going to take 126.5 and divide it by 2.5. Chase that decimal out of there and unpause when you're ready to see if your solution is correct. Okay, here we go. Our divisor, 2.5, we don't like that decimal in there, so we're going to move that to the right. And then we're going to do the same thing on the inside. We move that to the right one spot, and that's its new final location. So this number is now a 25 in front. It's no longer 2.5. Here we go. Does 25 fit into 1? Nope. Does 25 fit into 12? No. Does 25 fit into 126? Sure it does. 25 times 5 is 125, so it fits in there 5 times. Think about money. 5 times 25, that's like 5 quarters. That's 125. And we'll subtract, and we get 1. If we drop down our next digit, we get a 5. Now be careful here. It's tempting to want to drop down a 0 as well, but does 25 fit into 15? No, we dropped our digit, and our divisor still doesn't fit in there. That just means that we're going to have a 0 up here. It doesn't fit even after we drop the number. So 0 times 25 is 0, and if we subtract, we get 15 again, but now we get to the point where we can drop the next 0. 25 into 150, that fits 6 times. 6 times 25 is 150. There's no remainder, and that means that we've got an exact quotient here. 50.6, and those are miles per hour. or if we wanted to round, we could call that 51 miles per hour. If you didn't get that, rewind and double check your arithmetic here to make sure that that works out okay for you. Okay, we did everything we set out to do here. First of all, we showed that decimals are really just a special kind of fraction, and we can express decimals as fractions where we have 10, 100, or 1000 in the denominator. We did a little refresher on rounding, how to determine where to cut our number off and whether or not our last digit remains the same. We saw that when you add and subtract decimals, you have to make sure to line up the decimal point. And we also did a refresher on how to multiply and how to divide decimal numbers. So that wraps up this section. We are at the point where we're going to be using calculators here. There's one more short topic dealing with order of operations that we're going to do. Make sure that you watch that video with this section as well, and we'll see you in the next lesson.